Okay, I've had a lot of questions about Project 5, and so I wanted to cover a few tips that may help you solve this thing. And so the maze that's in front of you is the same maze that is in the assignment specification. However, this may not be the maze that I actually test your code with, but I'm going to use this to basically explain what's going on. So let's assume, first of all, that that the order of exploration for this particular maze, we're just going to set one. Okay, so let's assume that we're going to go east first, and then we'll go west, and then we'll go north, and then we'll go south. Okay, so basically, obviously east is in this direction, and here's west, and here's north, and here's south, pointing down. Okay, so now we've already obviously started, so we always start at the top left, and so we moved from here, from this top left, and we moved east. So we're here now. And then we moved east again. So we're here at this point. And now the next move would take us here. Okay? And we're okay. Now, the very next move is going to take me inside this wall. Okay? But I'm still going to make this move, right? This is important. Again, we're solving this via recursion, so you cannot use any kind of a while statement or anything like that. Well, you should not use any kind of a loop. There is a place where you could slightly use a loop, but you don't want to solve this iteratively. Notice that when I'm here, I don't look ahead, and this is the point I was making in the specification. I don't look ahead and decide, oh, that's a wall, I'm not going to go there. I actually move from here to here as my east move. Now that I'm in this grid cell, I'm at an X grid cell. I'm inside a wall. So at this point, I backtrack. Okay, so backtracking simply means that I don't begin to move from here to here. That's actually processing a move. I don't want to do that. I want to go ahead and backtrack from this point. That puts me back in this grid square because I got to this as the east call of this particular grid square. That means that when I'm back inside this grid square, the east call has been taken. I now have to take the west call. Okay, I now have to explore to the west. Well, so I move in this direction. That's my west move. Well, guess what? I've already been in that particular grid cell, so I don't want to do anything. Okay, what's my next move? Now I've wasted my west move. That's gone. Okay? In this instance of the function, I have gone east and I have gone west. So the next thing to do is to go north. Okay? That puts me in this grid square. This grid square is a wall. I'm not supposed to be there. So I backtrack. And I have now wasted my north move. Okay? I only have one more move in this particular grid cell, and that's to go south. And going south puts me here. And I begin by doing what? Well, it's a brand new day. It's a brand new instance of the function when I get here. So my next move is to move to the east. Now you may be thinking this is not going to solve the maze, but it will in fact solve the maze. The key thing to remember here is that you have to process, the instance of the function has to only process a single grid cell. And there are various aspects of single grid cells. There's one with an asterisk, there's one with an X, and there's one with a no, and there's one with an E. So you have to be able to handle all of those inside the instance of the function. Furthermore, you have to explore you have to possibly explore all four directions in order to be able to know whether you've done the proper exploration. So now that we have that explanation, let's fill all of these in. Guess what? I wasted the east move when I went from here to here. No other moves have been wasted in this grid cell. That means that if I ever get back to this grid cell, okay, this instance of the function, so let me restate that. If I ever get back to this instance of the function, which is now in this grid cell, the next move I would make from here would be the west move, okay? It's the same situation here. I've already made this move. It's the same situation here. I've already made the east move. You notice that in this grid cell, I've now made all four moves because I went south and I ended up down here, right? So if I ever get back into this instance of the function, it will simply backtrack. Well, where did it come from? It came from here. Okay? And so you have to think about it this way, right? So the key to this is you're solving this using recursion, which means you're not looking ahead. You're just handling the situation that you're in right now. Every instance of the function is either the first time you enter it, it's a new instance of the function. Any other time that you enter it, you're inside that function somewhere. So if my code looks like this, you know, with a bunch of checks here, etc., and then I make my east move, and somehow I end up backtracking, well, a few statements later, here is my west move, and here's the closeout of the function, right? I also have a north move, right, and a south move down here, and the function closes out right here, right? So in this particular case, then, right, everything is laid out in one instance of the function. If I backtrack after the west move, I don't go back to the top of the function. I don't do this, right? No. If I backtrack and I've just finished the west move, the next move is the north move, okay? I've already used my east move in this case. I've used my west move. The next move is the north move. And that's how you have to think about it, right? And that's why we don't want to look ahead. For instance, if I was in this grid cell, I don't want to peek over here, and that's why I forbade you from doing that specifically. I don't want to look ahead and go, should I go there? That's not recursion, right? This is the same thing as looking ahead to see if you're at the leaf of a tree. You need to process all nodes in a similar fashion, right? Which means I go there. Now it's a brand new day, brand new instance of the function, but I have this x. Well, that means I shouldn't be there, so I let that instance of the function expire, and I end up back here, and now I've made my east move, so the next thing I want to do is to go off in this direction and end up here. Okay? I hope that is helpful to you.